Welcome, everyone. My name is Dr. Laura Cohen. I'm the Executive Director of the Harriet and Kenneth Kupferberg Holocaust Center at Queensborough Community College at the City University of New York in Bayside, Queens. Our mission is to use the lessons of the Holocaust to educate current and future generations about the ramifications of prejudice, racism, and stereotyping. Today's special event is entitled Albert Einstein, Refugee, Activist, and Humanitarian, featuring Michael Shara, the American Museum of Natural History professor and curator of the 2002 landmark AMNH exhibition, Einstein. The Kupferberg Holocaust Center in Bayside, New York, is situated on the traditional land of the Mantinecock people who continue to live here today. We offer gratitude and respect to all of the indigenous people of Turtle Island, past, present, and future, including the Lenape and Shinnecock peoples. What I just read is what we call a land acknowledgement. And this is a statement recognizing that the land we all occupy in the course of our daily lives, including our schools, jobs, parks, and homes, as well as the names of towns and roads, were first inhabited by another group of people who were forcibly expelled and murdered. Today we identify those crimes for what they are, genocide and mass atrocities. And these horrors continue to have social, psychological, economic, and environmental impacts upon and within indigenous communities. We've got some students who want to enter the classroom, so I'm going to invite them in. If everyone would like to come on in. We're really excited to be hosting the event today online and in person, so come on in. Today's event is part of the 2025-26 KHC and National Endowment for the Humanities Colloquium entitled Resistance, Resilience, and Reinvention, Artists and Academics Escaping Nazism, and it's co-sponsored by 10 organizations around the country. And they include the Holocaust and Human Rights Education Center in White Plains, the Center for Genocide and Human Rights Research in Africa and the Diaspora in Northeastern Illinois University, the Center for the Study of Genocide and Human Rights at Rutgers University, the Holocaust, Genocide, and Interfaith Education Center at Manhattan University, the Ray Walpole Institute for the Study of the Holocaust, Genocide, and Crimes Against Humanity at Western Washington University, the Reef Center for Human Rights and Conflict Resolution at Christopher Newport University, the Holocaust Resource Center and Education Center of Keene University, the Institute for Genocide and Mass Atrocity Prevention at Binghamton University, Wagner College Holocaust Center, and the Queens College Center for Jewish Studies. We're really grateful for all of this support. I'd like to thank our colleagues from the Media Services and Digital Transformation departments, including Phil Roncaroni and Jesse Pina, as well as Borana Soman, the KHC's museum coordinator, and a special shout out to Mr. Mark Kupferberg, one of the center's benefactors and whose parents' names so graciously adorn this building. So before we begin, a reminder for those of you attending in person to please turn off your cell phone. And after the presentation, we'll host a Q&A. So for those of you here, we'll hand out a microphone so you can ask your questions. And for those of you online, if you could please drop your questions using the Q&A button at the bottom of your screen. And now it's my pleasure to introduce one of this year's KHC NEH Faculty Fellows, Dr. Beth Cunahan. Dr. Cunahan has been professor in QCC's English department for the past 24 years. She's active in teaching and coordinating high-impact practices, college and university science, service, and pedagogical scholarship. Her own scholarship includes numerous National Two-Year College Association presentations on nature-infused curriculum and reading in the community college classroom. And she was also corresponding co-author of a chapter about the QCC Common Read Initiative, which the KHC continues to support, for the 2017 text, What is College Reading? She's especially devoted to first semester QCC students taking part in the college's learning communities, service learning, the Common Read, as well as organizing the KHC-funded Welcome Read. Dr. Cunahan, the floor is yours.
Thank you to Dr. Cohen and to Borana Soman, my colleagues, Professor Cimino and Dr. Zelser, for working on organizing the colloquium together, our attendees in person and online, both present and future online attendees, and Dr. Michael Shara for coming today to present Albert Einstein, Refugee, Activist, and Humanitarian, our second lecture in the series, Resistance, Resilience, and Reinvention, Artists and Academics Escaping Nazism. In 1933, as Hitler consolidated power, thousands of Jewish and dissident artists and academics faced persecution not only from Nazi anti-Semitism, but also from the regime's totalitarian control over culture and society. As Nazism spread, many painters, writers, filmmakers, and scholars sought refuge in Europe and the United States, though restrictive and anti-Semitic immigration policies often blocked their escape. This series explores the history, the contributions, and lasting impact of those who escaped. Additionally, the series highlights the resistance and creative works that emerged from their survival. Please join me in a moment of silence in remembrance of those who did not escape the Nazi religious, intellectual, and artistic persecution, and those impacted by the Holocaust. Thank you. Thank you. So please join me now in welcoming our speaker today. Michael Shara is curator and professor in the Department of Astrophysics, Division of Physical Sciences, and professor in the Richard Gilder Graduate School at the American Museum of Natural History. Dr. Shara's research interests include the structure and evolution of nova and supernova, collisions between stars and the remnant descendants of those collisions, and the populations of explosive stars inhabiting star clusters and galaxies. He frequently observes with the Hubble Space Telescope and other large ground-based telescopes. His research team at the museum is currently surveying nearby galaxies for their explosive binary stars and simulating the evolution of these stars over billions of years. In 2002, Dr. Shara curated the museum's exhibit Einstein, and in 2011, he curated the exhibit Beyond Planet Earth, the Future of Space Exploration. So please join me in welcoming Dr. Shara.
Thank you. Thanks. Okay. Thanks very much for coming. Glad you're all here. And it's a real pleasure today to talk to you about Einstein and a part of his life that I don't often discuss. When I give lectures about Einstein, it tends to be about his life, which was very colorful, to say the least. Very, very interesting from many, many different perspectives, and also about his science. Because we live in a world today that is driven by Einstein's science. Some of the things that he invented or discovered or explained to us would eventually have been found by other people. Some of those things might have taken a century or more, but really the second half of the last century and then now the 25 years of the 21st century are entirely driven by the extraordinary accomplishments of this extraordinary man. So I'm going to tell you about the scientist and to some extent about the refugee also, because that's the topic. Well, what do people think about him or know about him? The vision that people have of him today is the picture that you see on the left, this wizened old man. This image was taken just a few years before he passed away at the age of 76. The more lighthearted version is the one on the right. You see E equals MA squared. There's a big cross through it. Nope, that didn't work. E equals MB squared. Nope, that didn't work. You know where he's going, of course, with all of this. So, let's see. Oh, okay. Nope. Thank you. So what I'm going to be talking about today for the first few minutes is his early life, but relativity, general and special relativity. So I'm going to teach you Einsteinian physics basically while standing on one foot. Some of the impacts on our world, basically everything, including the cell phone in your pocket, the computers we're using, even these cool lights, are entirely due to him. his refusal to be afraid, even when his life was in danger or when his physical safety, even in the United States, was in danger, because there were people who wanted to deport him even after he came as a refugee. His pacifism, his anti-racism, a little bit about the Second World War and his involvement in the development of the atomic bomb. And I'm just going to call this lecture Einstein on the Run. There's a wonderful book by that title that describes the years when he was very much on the run. So he was a great physicist who did great physics, was also a great humanitarian, and probably the most famous refugee of all times. So before I did the exhibition in 2002 at the American Museum of Natural History, and before we do any exhibition, we always ask the visiting public, who was Einstein, or what do you know about the topic? And here's a kind of summary of what people know. So you see a kind of atomic bomb, and there's this great head of hair, and people didn't know all that much else about him. Okay, this is 25 years after his death. Well, they were accurate about the hair. And here's a wonderful letter that I was able to exhibit. Dear Mr. Einstein, I'm a little girl of 6. I saw your picture in the paper. I think you ought to have your hair cut so you can look better. Cordially yours, Ann Cosin. Ann lived on Central Park West, just a few blocks away from the American Museum of Natural History. Priceless. The ascent of man, or of humanity, an image from the late 1940s, 1950s, which has been copied thousands of times and modified thousands of times. And it's as relevant today as it was then. Einstein, of course, is right at the top with E equals mc squared. How famous was he? Well, he was the most famous person in the world. Here's a letter sent to him from Indonesia. Mr. Einstein, the atomic scientist, USA. It was delivered in 3 days. There was no problem finding him. Here's his reputational evolution. So he appeared on the cover of Time magazine 6 times. Here are 4 representative ones. 1938, he's seen as this wizened cosmologist. He was referred to as the cosmologist, someone who had helped explain the fact that the universe is expanding. It was only discovered in the 1920s, and his equations from 1915, 1916 had actually predicted that the universe could not be stable, that it must have emerged from a tiny point and be continuously expanding. In 1949, when he was on the cover, you see him as deeply associated with the atomic bomb. This was only 4 years after Hiroshima and Nagasaki. In 1979, which is the centenary of his birth, he was born in 1879 in Ulm, Germany, you see stars and galaxies emerging from his head. So he's gone back to being the cosmologist, the person who helps us understand the cosmos. And then in 1999, bottom right, he is labeled by Time magazine as the person of the century, the most important person to live in the 20th century, the most influential person, certainly. And he has become Saint Einstein. Saint Einstein, someone unknowable, holy, what have you. And to me, anyway, this is the silliest of all, because he was a living, breathing, dynamic human being whose influence then and now continues to be felt right across the world. So I want to demystify. I want to take him from the 1999 cover back to the 1938 cover. Well, he actually was a little boy at one time. This is him in 1883. He was 3 or 4 years old in Ulm, Germany. And there are lots of things online that tell you he was a terrible student. He wasn't. This proves he wasn't. He was an excellent student. 6 is the highest grade. This is his high school leaving certificate. You see that in geometry, descriptive geometry, physics, chemistry, history, he got 5s and 6s, algebra. He wasn't terrific at languages, but he still did okay. But all in all, a really outstanding student, so don't let anyone tell you that he wasn't. Also, please don't let anyone tell you he was dyslexic. he was not. He, in fact, wrote, and I've held his Zurich notebooks in his hand, where he writes the most complex equations imaginable out all by hand. This was long before the days of computers, and he got it all right. So none of those two myths. By 1904, he had finished his PhD, in a sense against all odds, because his teachers did not like him. Einstein hated authority from the day he was born. He hated memorizing stuff, and much of the teaching, especially when he lived in Germany, was by rote, from teachers who were martinets, and you're going to do it my way or the highway. So he had a miserable time in school until his parents were able to transfer him to schools in Switzerland, where he spent his later teens, and he was vastly happier. By 1904, he had married Mileva Maric, a fellow student. They had a little girl just before they were married, and in those days that was something very, very shameful. She has disappeared to history. Various historians have gone tramping through the graveyards of Serbia because we know that she was very ill. She may have had, well, we don't really know for sure, but she has vanished. But he had two sons, and here we are with Hans Albert, who was the first child. He and his wife were separated for a while because he was at an academic post. She had to remain behind in Switzerland for a while. So he wrote love letters to her. And here is the beginnings of one of them. "My little kitten," he says, and the heart rate of every woman in the room should go up a little bit at seeing this. And then he continues, "I have just read the most marvelous paper on the production of cathode rays by ultraviolet light." Well, she was a scientist too, so maybe she thought this was very cool and sexy. So part one is going to be about his work and the implications of his work, and he worked on things of some import: light, matter, time, energy, and gravity. And in particular, he was able to show that atoms exist. Atoms had been postulated by the Greeks 2,500 years before, and by many philosophers, but there was no way of seeing one or touching one or measuring one or knowing what the smallest constituent of matter was until Einstein. And because of our understanding of atoms and how they form into molecules, today we understand DNA and genomics. Because of his work on the photoelectric effect, all of electronics, computers, lasers, the internet, the world today is entirely due to him. He was not the person who invented or discovered either fission or fusion, but he understood intimately what the power was, and it was he, more than anyone else, who set the United States on the course towards the Manhattan Project and the development of the atomic bomb, with a single letter that I'll show you shortly. The other critical aspect of everything that he did, especially with E equals mc squared, is our understanding of fusion. Because fusion is the source of the power of the stars, and in particular the sun. And of course, without the sun, life on Earth would be, well, if it existed, it would be vastly different from what it was. So the ability to understand how the stars shine and how the sun shines is entirely due to his work on special relativity. And then finally, gravity. Gravity is and was the most extraordinarily difficult problem. A great step forward was made by Newton 4 centuries before, when he wrote down a series of equations that let you calculate how the Earth goes around the sun, how the moon goes around the Earth, and ultimately how the sun orbits our Milky Way galaxy, but not why. So the how, and to be able to predict where things would move, was known for 4 centuries, but why it works like that, that's the spectacular step forward that he made beyond Newton. So he was also not just a humanitarian, but a human full of contradictions. He was a pacifist, deeply pacifistic person who is deeply associated with the atomic bomb, a socialist who during the Second World War was staunchly pro-American, but who also accumulated an enormous FBI file and strongly anti-McCarthy. He was not a religious person, but he was Jewish, had a strong Jewish identity, and was central to the establishment of the Hebrew University at Jerusalem. And he was a very, in his personal life, a very warm and gentle person with an extremely chaotic family life. So this is a picture of a drop of milk. And until Einstein, there was no real understanding of why the little droplets of fat vibrated. If you look at a droplet of milk underwater, you'll see that all the thousands, millions of little droplets of fat vibrate all the time. And Einstein understood it was because water molecules, not atoms, but two hydrogens and one oxygen atom, are banging randomly in all directions into every one of these fat molecules. And if a particularly energetic molecule whacks into a fat globule from one side, it'll jitter a little bit more to this side than to that side. So this phenomenon, the idea that microscopic objects vibrate all the time, was the key that Einstein used to show that atoms exist, and he was able to calculate from first principles how fast they move, how massive they must be. And there was then a flood of experiments that followed on after this that have proved over and over again today that atoms exist. And today there are electron microscopes that in fact can see individual atoms. But the proof came in 1905 with his paper on Brownian motion. There is also the photoelectric effect. I won't go into the details of it, but if you shine ultraviolet light, however weak, on a piece of metal, electrons will come popping out. But if you shine weaker red light, no matter how bright, no electrons will emerge. That was a mysterious thing that nobody understood. Einstein realized it's because light has both particle and wave properties, and ultraviolet light has more oomph, more energy, because its wavelength is shorter. You can think of it as a tightly coiled spring of energy that when it enters a piece of metal, a single photon, a single bit of light can provide enough energy to kick an electron out of a piece of metal, whereas thousands or millions of red photons, much less energetic photons, cannot kick out even a single electron. So the idea that matter is quantized in tiny little pieces and that light is quantized in little bits called photons was something that he demonstrated with his work on the photoelectric effect. And then in the same year, 1905, after explaining Brownian motion, the existence of atoms, after demonstrating that light is made of photons, individual particles of certain energies, he then went ahead and told us that space and time are inexorably and intimately connected with each other, and that the faster you move through space, the more slowly you move through time. The more quickly you move through space, the more slowly you move through time. In other words, if you and I synchronize our watches perfectly, if we have the best atomic clocks in the world, and I then take off, hop on a jet plane and circle the world once or twice and come back, your clock and mine will no longer be synchronized. Because time is not absolute. Time flows at relatively different rates for people moving at different speeds. Now, you hear me say this, and you think to yourself, if you're not a physicist, we need to get this guy a straitjacket, okay? He's crazy. But this is really the way the world works. Time is not absolute. Einstein first explained this to us. he also taught us that energy and matter are the same thing, different aspects of the same thing. Just like British pounds and US dollars are the same thing. They're both money, and there's a conversion factor between them. You need, I don't know, maybe 1.5 US dollars to buy a British pound at some point. So the conversion factor is 1.5 on a given day. Well, with matter and energy, the conversion factor is 1 with 21 zeros behind it. E equals mc squared. C squared is that conversion factor, the speed of light squared. So energy equals mass times the conversion factor, which is 1 with 21 zeros. So a tiny bit of matter will release a great deal of energy. And finally, and most profound of all, and the reason that he is really on this pedestal and there is no one who can touch him, is because he explained gravity, how gravity works. And he said, gravity works, the Earth goes around the sun, not because there is an invisible hand reaching out from the sun to the Earth, but because we are immersed in space and time, which is elastic. Space and time can be bent, can be warped, and the Earth moving around the sun is the Earth moving through a bent or warped space, and the sun is doing the warping. So in 1905, he produced papers on special relativity, Brownian motion, the photoelectric effect, for which he was awarded the Nobel Prize. And the Nobel Prize, which was for the year 1921, awarded in 1922, was not for relativity. It was not for general relativity, not for special relativity. It was for den fotoelektriska effekten, for the photoelectric effect. And that was because the Nobel Committee were frankly scared. They did not want to award the prize for something which might eventually be shown to be wrong. And relativity was scary. Relativity was terrifying to physicists. It basically took 4 centuries of ideas, and in some ways, ideas all the way back to Aristotle, and dropped them in the trash, okay, and started all over. But the photoelectric effect made predictions that were already affecting the world. And so, no matter what, the committee could not get it wrong by awarding him the photoelectric effect. When he got up to give his Nobel Prize acceptance speech years later, or in place of it because he couldn't physically attend, he talked only about relativity. He ignored the photoelectric effect. He thought it was a rather minor paper by comparison. There's his medal. And there is a kind of graphic demonstration of the fact that a moving clock runs slowly relative to a stationary clock. That yields something very wild called the twins paradox. So just to drive it home, I'll take one last minute to talk about that science. Imagine 2 twins born simultaneously, absolutely simultaneously by cesarean section from the same mother, and one of them is immediately kidnapped by her nanny, who jumps on a spaceship and travels away from the Earth at 99.999% the speed of light, out to Alpha Centauri, the nearest star, which is 4.3 light years away. Has pangs of conscience when she arrives there, turns around and comes back to the Earth at the same high speed. So 8.6 years have transpired on Earth, and the little twin on Earth is now 8.6 years old. But the nanny carries the baby off the spaceship, and the baby is only a day old, because moving very quickly close to the speed of light, time has hardly passed for her. So moving through space quickly means that you move through time slowly, and there are thousands and thousands of physics experiments which have verified this in hundreds of different ways. If you find that a little hard to wrap your brain around, let's quote Einstein on relativity. He says, a pretty girl sits in your lap for an hour. It seems like just a minute. You sit on a hot stove for a minute. It seems like an hour. That's relativity. Finally, gravity, how does it work? Well, imagine a large trampoline, large, very taut trampoline. You take a cannonball and put the cannonball in the middle of the trampoline, and you distort the surface of the trampoline. Now, before you put the cannonball on the trampoline, if you roll a marble across the surface, the marble will follow a straight line because the surface of the trampoline is perfectly flat. And the shortest distance between 2 points on a flat surface is a straight line. But on a curved surface, that's no longer true. And so if you take a little marble and roll it across the surface here and roll it just right, the marble can roll around the cannonball. If it's moving just the right speed, if it's moving too slowly, it'll fall in. If it's moving too quickly, it'll escape. But the cannonball is not touching the marble. The cannonball is distorting the space, which is what causes the marble to move around it. In exact analogy, the Earth orbits the sun because the sun bends space and time around itself just at the right amount for the Earth to be in orbit around it. Spectacular result. It also, this theory, makes other predictions. For example, it predicts that the orbit of Mercury, which is not a circle, it's an ellipse, will not always stay in the same place. It will precess. It will move. That is, the point where Mercury is closest to the sun will change direction over the course of many centuries, something that astronomers had observed by the mid-1800s and had no explanation for. There was no way of explaining it. In 1915, when Einstein wrote down his equations of general relativity, he was able in an afternoon to completely explain and predict that this phenomenon, why this phenomenon happened. And with it, he knew he was right. He knew that he had found the cause of gravity. But to really get buy-in from the world's physicists, he had to make another prediction, and that was that gravity changes the direction in which light moves. Why? Well, for the same reason, because the sun, for example, bends the space around it, so light moving by the sun from a very distant star that happens to be in the same direction as the sun will have its light rays bent. And so if you're looking at a star near the limb of the sun, which can be done, I'll tell you how in a minute, you will actually see the star appear further away from the sun than it really is because of the bending of those light rays. Well, how can you possibly see stars next to the sun? The answer is you wait for a total eclipse. When the moon passes right in front of the sun and blocks out the disk of the sun, the stars come out. You can take pictures, you can take images, and then you can compare the positions of the stars relative to each other before an eclipse and during an eclipse and see whether the stars are deflected from their positions or not. Well, between 1914 and 1918, there was a bitter, horrible war ongoing in Europe. Einstein made his predictions when he was living in Germany in 1915, in the middle of the First World War. And Sir Arthur Eddington, the leading British astrophysicist who was a pacifist, wanted after the war for Germany and England to reconcile, at least scientifically. And so he organized and led an expedition to go take pictures of a total eclipse that happened in 1919, just after the war. He was in correspondence with Einstein, told him fair and square, either your theory's right or it's wrong. If it's right, I'm going to tell the world. If it's wrong, I'm going to tell the world. Scientifically, very, very responsible. This great expedition showed that Einstein was right. And Einstein catapulted from an obscure physicist that no one had heard of except in the physics community to a world celebrity. Okay? He became as famous as the President of the United States and Lady Gaga rolled into one. He became a rock star absolutely overnight. Years later, he was driven half mad by a physicist who said, oh, there's so many other things you can do with your theory. In particular, this bending of light, it's not just starlight by the sun, but you can also have stars bent and distort each other's light. So he wrote a little paper that he dashed off in an afternoon predicting something called gravitational lensing, basically to get someone who was nagging him off his back. Today, this is an active subfield in astrophysics that those 5 points of light you see are actually just one point, one galaxy that is being focused by another galaxy. And we see even more powerful effects of this in the dark matter. 5/6 of the matter in the universe is not made of you and me. It's not made of protons, neutrons, and electrons. It's made of something that's called the dark matter. Astrophysicists have no idea what it is. It dominates the universe. It's the physics of Star Trek. We're going to need to understand it if we are, I think, to travel to the stars in the 23rd or 24th century. But it is because of Einstein and his physics that we know how to explain this phenomenon. And finally, black holes. Okay, black holes are everywhere in our culture. If instead of a 20 or 30 pound cannonball, I take a 5,000 pound cannonball and put it on the trampoline, I'll tear a hole in the trampoline. If I take enough matter and smash it into a small enough space, I create a black hole. I basically create a kind of tear in space and time, also predicted by general relativity by Einstein. So by 1919, Germany had surrendered after a bitter 4-year war. The Treaty of Versailles was imposed on Germany. The war guilt clause of Article 231 in particular was very, very harsh. Most of Germany's military was taken away. Germany lost Alsace-Lorraine. It established the League of Nations, and $33 billion in reparations to France and the Allied powers that Germany would have to pay. In essence, Germany would be broken financially for the next 100 years. Well, what this led to inevitably was chaos. Chaos in Germany, where as the German government started to reduce the army to comply with the Treaty of Versailles, several brigades of the German army refused to disband. There were threats of assassination against the politicians of the Weimar Republic who were trying to be compliant with the Versailles Treaty. A right-wing nationalist group called the OC, the Organization Consul, led by Captain Hermann Ehrhardt, started to acquire more and more power. And the most prominent two murders were those of, and to carry out assassinations, but in particular that of Walter Rathenau and Matthias Erzberger. Rathenau was a good and close friend of Einstein. He was, I've tried to describe him as something like perhaps Henry Kissinger, many, many things. He was both an industrialist, but he thought the world of Germany, the German classical traditions, and he described his actions as being guided by the German spirit which is sung and thought of the world. And he despised the kind of hatred that was beginning to consume Germany. So he was murdered on June 24th, 1922. As I said, a close friend of Einstein's. And at that point, Einstein saw the writing on the wall. He realized that he too was in danger with the rise of Hitler. Now, Hitler was arrested after his first attempt at a coup, but he was only sentenced to 5 years in prison. And Einstein realized that there were lots of Hitler's followers still out there. So in 1922, he fled Berlin for the first time, and this is where he became a refugee, not a permanent refugee, but he kept a very close, kept a diary, which has been edited by Zev Rosenkrantz at the Einstein Papers Project in Pasadena. And he decided that he was going to get as far away from Germany as he could. So he went to the Far East, to Japan, to China, Hong Kong, Singapore, and then on the way back, he went through what was then called Palestine, what we would today call Israel, and finally stopped for a 3-week visit in Spain before returning to Germany when he felt that it had become a little bit more safe. He missed it. He missed the German language in particular. And he also was convinced by some of his friends that his presence could be helpful. So here he is on his way to Japan. He is with his second wife, Elsa, who is also his cousin, aboard a Japanese ship. Here he is being entertained in Japan. The Japanese were thrilled to have him. Virtually every night that he was there was a party, a gathering. He gave multiple lectures. Here he is at Kyoto University on December 15th, 1922, with the entire physics department, physics faculty surrounding him. And then on his way back, as I said, he stopped in Jerusalem. This is in 1923, where he had been talking and become more and more convinced there was the need for a Jewish university, a Hebrew university in Jerusalem, and he is one of its key founders. When he passed away in 1955, he left all of his papers and all of his memorabilia to this university where all of these things still are, then went on to Tel Aviv, then on to Spain, and finally made the fateful decision to return to Germany. This is me with the past president of the Hebrew University, and we're standing in front of Einstein's library. This is in Jerusalem. It's a glorious collection, and next year, actually, ground has been broken for all of his papers, all of his memorabilia on a beautiful building that's going to be at the entrance of the Hebrew University in Jerusalem that will open in 2028. Okay. By 1928, 30, he was really at the height of his fame. He was the most famous, not just scientist, but I would say person in the world. He was invited and paid at the time what were very large sums of money by various American universities, in particular the California Institute of Technology, to come visit. The discovery that the universe was expanding, that we didn't just live in an assemblage of a few million or tens of millions of stars, but in a galaxy of 100 billion stars, and that there were billions of galaxies, had been made in California at Caltech by Edwin Hubble. And here he's standing on the right with two of the greatest physicists of the time, Albert Michelson, who showed that the speed of light is always measured the same by all observers. If I shine a flashlight at you and you measure the speed of the photons arriving at you, you will measure 186,300 miles per second. And if I'm standing still or running at you at half the speed of light, you will measure exactly the same speed. Now, that's not true of baseballs, for example. If I throw a baseball at you at 100 miles an hour, you'll catch it, and it'll arrive at basically 100 miles an hour. But if I'm moving at 50 miles an hour towards you and throw the baseball at 100 miles an hour, it'll arrive at 150 miles an hour. Velocities are additive at low speeds. Near the speed of light, that's not true, as Michelson first showed, and that was the key that let Einstein explain relativity. So the experimental basis for relativity was explained by the man on his right, and the man on his left was Millikan, who had first measured basically the mass of an electron and showed that electrons and eventually protons and neutrons are these tiny, tiny, tiny particles which carry charge and of which ordinary matter is made, and all of electronics, that is the control and the flow of electrons, which is the basis of our civilization, came from the man on his left. So you have three of the smartest and most important physicists who ever lived standing next to each other. Well, when Hitler came to power in November 32, after being released from prison, writing Mein Kampf, and organizing his followers more and more, he was able to achieve total dominance, topple all democratic institutions within a year. And Einstein was on his way back when this happened from California, his third trip to California. He stopped in Belgium on the way back, fortunately. The Queen of Belgium was a great fan of his, and she helped organize squads to protect him from assassination. It was clear that he was going to be assassinated if he returned to Germany. He resigned from the Prussian Academy of Sciences. He renounced his German citizenship. His home and bank account were confiscated by the Nazis, and he was marked for both arrest and assassination. After 6 months in Belgium, it became clear that his situation really was fraught, and it also was not clear what the Germans' intent was. Well, it became more and more clear that they were going to invade the rest of Europe. He was smuggled across the English Channel on a small boat to England, and while there were several MPs from the Conservative Party who took a great deal of interest. They were, you know, they knew what a treasure they had, so they guarded him continuously. And here he is in Belgium. There is to this day a lovely statue of him at the little seaside resort where he stayed. There is this magazine that is very popular in Belgium, and he was called Coq sur Mer, the chicken at the sea. He was being chased by this fanciful blonde Nazi agent to his right. We don't actually have any images of anyone trying to kill him, but it's pretty sure that if he had stayed, his life wouldn't have been worth anything. There he is in England. He was not kept in London. He was at a small town well outside of London with armed guards. These were civilians who took it upon themselves to guard him 24/7 for the 6 months that he was in England. And he was immensely grateful to the English. He realized that both the Belgians and the English had saved his life, and he was grateful to them for the rest of his life. Just before he left in October 1933, he gave an address at the Royal Albert Hall where he was fundraising for academic refugees. There was a flood of people, artists, scientists, and politicians who were desperate to get out of Germany, and it was still possible to do so at that time. Conditions were horrible, rapidly deteriorating. If you were Jewish, your life was already under threat continuously. So he was the fundraiser, the chief fundraiser at Royal Albert Hall, trying to get as many academic refugees out of Germany as possible. He was invited to the United States, arrived in late 1933 here in New York, to great hubbub and fanfare, hundreds of writers and newspaper people at the docks waiting for him. And there had been a bidding war between Princeton and the California Institute of Technology. Princeton made him an offer he couldn't refuse, basically could do anything terrific salary, a house, complete academic freedom for the rest of his life. All he had to do was science. So he took it, and he continuously spoke out on the causes and cures of war. He remained all of his life a dedicated pacifist, so sent letters to the anti-war committee at New York University, made a national radio speech on Brotherhood Day, sent messages to the educators and the World Peace Conference of the Progressive Education Association in New York, and so on and so on. This is just a very partial list of just 2 years, but he became an activist. He used his name, his fame, to promote civil liberties, to promote and to try and do anything he could to help his fellow academic refugees. In 1940, he became an American citizen. Here he is taking the oath of citizenship with his niece and with his secretary. Notice the footwear. Take a close look at the footwear. You'll see that he's not wearing any socks. Einstein marched to the beat of his own drummer. What was he deadly serious about? And that was Nazism. He saw that as the most evil force that had ever arisen in the world. And despite the fact that he was a pacifist, when several fellow physicists came to him and said, listen, we have just heard that in Germany, the atom has been split. That is, the process of fission, splitting of atoms is possible. But more important, when you split an atom, the fragments that come out at very high speed. And there's this wonderful example. Many of you probably are too young to have ever seen this, but Walt Disney is seen in the 1950s standing with his back to a very large room, and the room is filled with mouse traps, thousands and thousands of mouse traps. Each one of those mouse traps has got a ping pong ball loaded on it. And what he does is he throws a single ping pong ball backwards into that room. Well, one of those ping pong balls hits another ping pong ball and the mouse trap snaps. And then there are 2 ping pong balls, and then 4, 8, 16, 32, 64, and you hear snap, 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 snap. You get a chain reaction. You get a runaway chain reaction. And the physicists in Germany and in the US immediately understood that it might be possible to build a chain reaction. So Fermi and Szilard came to Einstein, told him about this, and asked him to write a letter to President Roosevelt. And on August the 2nd, he sent this letter to Roosevelt and said, in the course of the last 4 months, it has been made probable through the work of Joliot in France, as well as Fermi and Szilard in America, that it may become possible to set up a nuclear chain reaction in a large mass of uranium, by which vast amounts of power and large quantities of new radium-like elements would be generated. It appears that this can be achieved in the immediate future. This new phenomenon would also lead to the construction of bombs. And it is conceivable, though less certain, that extremely powerful bombs of a new type may be constructed. A bomb on a ship, for example, could destroy an entire port. Roosevelt wrote back, thanking him for his letter, and immediately convening a board by the Bureau of Standards to begin to investigate the possibilities regarding the element of uranium, and work on the Manhattan Project had begun. Well, the fundamental explanation for why an atomic bomb works is Einstein's equation, E equals mc squared. Dollars and pounds are the same thing with a conversion factor. Energy and mass are the same thing with a much larger conversion factor. That 10 to the 21, the speed of light squared, is why 1 kilogram, about 2 pounds of uranium, in a small little sphere brought together into a critical sphere, can produce enough energy to destroy an entire city. It also explains why the sun shines. The sun takes about 4 million tons of hydrogen in its core, which is at about 17 million degrees, and fuses the hydrogen at high temperatures into helium. That produces X and gamma rays, which trickle out to the surface of the sun, and 30 million years later, the average photon, that's how long it takes to trickle to the edge of the sun, escapes, and that's why the sun shines. Physics isn't bad. Physics isn't evil. Physics is neutral, okay? It explains how things work. People sometimes use it to do beautiful things, like explain how the sun shines, and sometimes to do terrible things, like make atomic bombs. Einstein had a very, very interesting circle of friends, including a lot of people that the FBI considered highly subversive. Does anybody recognize the subversive in the center of the picture? That is Charlie Chaplin, correct. You can go to www.fbi.gov if you're interested, and you can read his 1,800-page long file. The FBI, 1,800 pages. J. Edgar Hoover wanted to deport him, considered him a communist. He certainly was a socialist, self-avowed socialist, very controversial in his time, and never afraid to speak his mind, ever. He also despised American racism. One of the most famous opera singers in the world at the time was Marian Anderson. Marian Anderson was black. She was invited to come to Princeton to give an opera recital at Princeton University. She did. It was, by all accounts, a smash hit. Somebody had made a reservation for her for that evening to stay at the Princeton Inn. When she arrived, they refused to give her a room because she was black. It was segregated. Einstein heard about this, was enraged, was only a few blocks away, immediately invited her to come stay with him, his secretary. He had a little entourage at their home on Mercer Street, and she did, and they became lifelong friends. He also went and gave several lectures at Howard University in DC, where he spoke really quite contemptuously about American racism. During the McCarthy period in the early 1950s, he advised intellectuals who were called in front of the House Un-American Activities Committee to refuse to testify. Okay, he said, you have the right to remain silent, that is certainly true, but you also have the right of free speech. He said, that is the clause that I would invoke, even at the risk of jail and financial ruin. He died in 1955. This is his, if you will, epitaph by Herblock in the Washington Post. Einstein lived here, the father of our understanding of the cosmos, an extraordinary man, a remarkable man, who was, for the last 22 years of his life, a refugee from Germany. He never returned. An outspoken person, a brave person, someone I think that there is much to admire and emulate. As an epilogue, one of the most dramatic predictions he made in 1916 was that of gravity waves. That is, imagine, let's go back to that trampoline with the heavy weight in the middle of it. If I tap on the edge of the trampoline, then waves will propagate through the surface of the trampoline. The speed of the waves will depend on the tension in the trampoline, but waves will move back and forth so that if I tap on one side of the trampoline and I put my hand on the other side, I'm going to feel it vibrate. Similarly, Einstein was able to predict that gravity should propagate in waves, moving at the speed of light, and the merger of two black holes, though he didn't calculate this explicitly, would give rise to a burst of gravitational radiation, which was finally observed in 2016, 100 years later. In the lower left picture, you see the observatory, one of the 3 observatories that actually observed it. The ripples in space and time, the amplitude or the height of the ripples in space and time are 1,000th the diameter of a proton. And yet today we have the technology to be able to measure such things with exquisite precision, yet a further confirmation that his theory of relativity was correct. And I'll close with a quote from him. He said, "I have no special talents. I'm only passionately curious." So thank you for bringing your curiosity to this talk. It was really a pleasure. Thank you.
Thank you so much, Michael. That was really tremendous. And I can tell you that everyone here and also online is wrapped. So I'm going to stop sharing the screen. And for those of you online, we're going to take a 2-minute break so we can set up for Q&A. All right, so we're going to get started with questions, and I wanted to, again, thank everyone online and who's here. And while we're getting settled, Michael, my first question is, before your talk, you were speaking about how successful the exhibition on Einstein was, and that it toured around the world, and at some point it was kind of a little ragged because it had been seen so much. What is the reason why you think it was so popular? And in all the presentations you gave, was there certain insights about Einstein or connections people made that really kind of stuck with you?
That's a terrific question. We were pretty sure that Einstein would be a smash hit, in part because the American Museum of Natural History has been doing exhibitions now for more than a century, and we always survey our audiences. And whether it's elephants or whether it's whales or whether it's dinosaurs or whether it's extremophiles, the toughest little critters, people and children in particular tend to connect with these things and come because they're fascinated by these creatures. We've only occasionally done exhibitions based on people. The other smash that was done around the same time was Darwin. In many ways, the father of modern biology, biological evolution. Einstein is the father of physics and modern science. So the fact that we could both connect this icon of a human being with science, and people instinctively understood that their lives today are very, very, very deeply influenced by everything he did, that seemed to be the hook. And we tried to take advantage of that. Okay, we are, after all, in the business of edutainment. That is what we do. We understand that. We are scientists, we are a research institution. There are 50 PhDs, 50 PhD faculty, and another 50 postdocs and what have you, and we do science very intensively, but it is also our business to both educate and entertain the people who come to us. And Einstein was one of those rare topics where we could do both, where we had a human connection, because as much as you love whales, you're not a whale. You're never going to be a whale, or a gorilla, or a dinosaur. Children identify with them. But Einstein was someone that many human beings could connect to. So there was a certain power that he had. We had about 550,000 visitors over the course of 6 months to Einstein, and then it went to 25 or 30 other venues around the world where of order 10 million people saw the exhibition.
That's 10 million people.
Yep.
I don't know where to begin with that. Beth, I wanted to turn it over to you to ask any questions, or you've also brought your classes here.
Yeah, do we want to open it up to the students or anyone in the audience?
Don't be shy.
What year was that exhibition at the museum?
It was 2002, 2003. Then it went to the Field Museum in Chicago. It went to the Boston Museum of Science, to Los Angeles, Istanbul, Alexandria, Haifa. It kept on going. And I mostly got to go to the openings. It was a lot of fun.
Anyone else here have a question? We're going to pass the mic if you could ask your question into the microphone.
No.
How are we to prevent applying electronics, prevent it from being used as a weapon on person's head, body?
How is one to go about doing that? You can't. You can't.
Can legislation be introduced to
It can be.
oppose it to condemn use of electronics as
I'm sure it
weapon?
can be introduced. Maybe in certain legislatures it can be passed, and I'm sure it cannot be enforced. It's just the nature of human beings. Once the genie is out of the bottle, once technologies become available, they diffuse worldwide. Scientists are blabbermouths. We're very proud of our accomplishments. It is against our nature to keep anything hidden, even things that maybe shouldn't be discussed. When I make observations of a nova in the Andromeda galaxy, or colleagues discover gravitational waves, or a black hole, or someone finds a new kind of virus, what happens? Well, next week it's in Nature, okay, or in the Astrophysical Journal, or in the Physical Review Letters, or something. The nature of science is, the only way science progresses is via communication, so all of these things are disseminated. Now, maybe in the United States, we're opposed to certain uses of certain technologies. Chemical weapons, for example. I think we can all agree that this is not a great thing. We don't want mustard gas running around all over the place. But that doesn't mean that there aren't bad actors who can read how to make this stuff and make the stuff, and that there aren't large stores of it worldwide. So I think in all cases, including all kinds of electronics, the genie's out of the bottle. There's no way of stopping it.
Hello, I came a little bit late, but I wanted to know more about your thoughts and techniques for getting younger people, or even just young people from a large range of ages. How do you get them to be critically engaged with more abstract ideas, theories, and ideologies that academics, like yourself and myself, that
Yep.
we just kind of blubber on about and we get so excited to talk about them?
Right.
But how can you critically engage the youth in these kinds of ideas and thought processes?
Sure. So one of the one of the reasons that I left, I was at the Johns Hopkins University for about 17 years at the place that runs the Hubble Space Telescope. And I was joking before, but only half joking. I was the most hated and feared man in all of astrophysics because I was responsible for the peer review committees for the Hubble Space Telescope. And that was great, and I was deeply immersed in probably the most important astrophysics experiment of all time. And it has taught us, for example, about the existence of dark energy, which makes up a significant fraction of all the mass energy in the universe. And then I made a conscious decision to move to New York City, to move to the American Museum of Natural History every year, because we have 5 million visitors a year. And yes, I lectured on physics or mathematics or what have you at Johns Hopkins, and I would teach 10, 20, 30, even 100 students at a time. But we have 5 million visitors a year at the Natural History Museum. So that's a whole different ball game. That's scaling up tremendously. There are programs that we do in order to try to leverage the limited resources we have. So in addition to reaching those 5 million, we also, for example, teach students. Students get their master's degree through us. We are a graduate program, and they are master teachers. So they learn earth sciences and astrophysics, and there's no tuition, they're not charged a penny, in fact they're paid a stipend, but they have to pledge to spend 5 years in New York City and New York State public schools teaching science. We now have, I think, 300 graduates from that program. They are a significant fraction of all the science teachers in New York City. So it's not just teaching or going into classrooms, but it's using the resources you have to leverage what you have in order to get many people involved in doing this. And elementary school and high school teachers in particular, are critical in this mission. If you don't excite somebody about science, or at least expose them to it between the ages of, say, 12 and 18, and actually get them doing some hands-on science, laboratory science, you've lost them. The chances of ever catching them afterwards are virtually zero. They might read the New York Times, they might read Scientific American, but they're never going to be a scientist. And not everybody should be a scientist, okay? Only a small fraction of the population can be supported by any society. Maybe when we have robots taking care of everything for us, we'll all be able to be scientists, but that's a long way off. So the short answer to your question, which is a terrific question, it's largely in high school. You've got to engage kids. You've got to make kids excited about science, and just as important, girls are 51% of the population, girls in particular, because they drop out faster, because they tend to be discouraged. They used to be discouraged more by their teachers. I like to think that that's no longer the case, or by their parents. And by setting examples, by opening doors rather than closing them to children of all backgrounds, okay? All races, creeds, colors, etc. Science is largely blind these days, finally. But 2-3 generations ago, it wasn't. It was a white man's world. That's all it was. Old white men occupied all the positions of power. Happily, that's not true anymore. So we're moving in the right direction.
So we've got some questions online. I'm going to ask you two kind of more technical. One is the following true? After Germany surrendered, did Albert Einstein lobby the U.S. government to not use the atom bomb on Japan? And the other is kind of related, which is, can you talk more about Einstein's atheism or humanism and his rejection of religion?
Sure. Einstein was aware, so Germany surrendered in April of 1945, and Japan remained at war, and it was a bloody, bitter conflict across the Pacific. It became increasingly clear to everybody involved in the Manhattan Project and to Einstein that the bomb was not going to be used on Germany. They had surrendered, but that Japan might well be the target. Now, Einstein himself was not involved in the Manhattan Project. He was considered by many to be too much of a security risk. He was too much of a lefty to be trusted with these deep secrets, even though he was the one who had brought them to the attention of President Roosevelt. He did work for the Navy on a pro bono basis on various kinds of torpedo designs. So people did bring him work, he reviewed it, but it was all mechanical stuff. And he had worked, I didn't mention this, but he had worked in the patent office in Bern, Switzerland for 10 years after his PhD because he couldn't get a teaching job. Okay, none of his teachers would write him a letter of recommendation just because he was, he was smarter than they were. And he occasionally let them know that he was smarter than they were. So, he wasn't great at making friends and influencing people in the academic chase, and he was actually very grateful for that job. So he understood how stuff worked because he had worked in the patent office, and so he was able to make some contributions in making better torpedoes. And he knew that these torpedoes were not nice things. They were designed to sink ships and kill soldiers, kill sailors. That's what he did. He understood that. There is no record that I know of, and no letter, for example, of him writing to Roosevelt, for example, or to Harry Truman and saying, please don't use the atomic bomb on the Japanese. He was not supposed to know of the existence of the bomb. He wasn't in Los Alamos, and nobody was reporting to him about what was going on. But he had his ear to the rail, and he probably knew. So I think the answer is no, not actively. He did not try to dissuade anyone from using the bomb on the Japanese. And of course, once the bomb was built and the war was ongoing, the genie was out of the bottle. There was no way that the United States was not going to use it. With tens of thousands of troops, American troops being killed every day, Truman made the decision, and it was not a hard decision for Truman to make. Second question was religion.
Yeah,
Okay.
can you talk about his atheism or humanism, his rejection of religion?
Right. Like all of us, he went through changes in his beliefs and practices. So he was born a Jew, died a Jew, identified as a Jew, was persecuted as a Jew, would have been assassinated as a Jew had he stayed in Germany, but never attended synagogue, was not religious in any formal sense of the word, considered himself, we would probably use the term a cultural Jew today. He thought about where the universe might come from, what the old man, he sometimes used that term with reference to God, what he was thinking. And there's a beautiful exchange between him and some of the quantum physicists, because while he had explained gravity, the people who were developing quantum mechanics, some of it using some of the stuff that he had done in developing the photoelectric effect, had come to realize that the universe at a very, very small scale does not obey Newton's laws of motion. There's a whole new set of equations called quantum mechanics. We call that quantum mechanics today. And quantum mechanics is fundamentally probabilistic. I can tell you with a high degree of probability what an electron at a certain position of velocity is going to do, but I can't tell you with absolute certainty. And Einstein found that idea repulsive. He famously said, I don't believe that God plays dice with the universe. And the retort to him was, don't tell God what to do. Today, we understand that quantum mechanics is right. The universe is fundamentally probabilistic. And to try to tie those two together was into a single, what we call today a unified field theory or a theory of everything, was both his life's work and the work of many physicists who came afterwards. And in some sense, that was, I won't say his religion, but his core set of beliefs. He was trying to understand the unity and the beauty of physical law within the universe, and that's something he did take very seriously. By the same token, he also realized that the laws of electrons and black holes and what have you are not the same as the laws of humans. How humans need to treat each other and behave with each other is something fundamentally different. And you can call that religion, you can call that ethics, whatever you want. He was, again, a pacifist, despised the use of violence, felt all people were equal. This, if anything, was his religion.
Another question that's come in is how was his stint at the patent office how did it inform and influence his science? Were there important social aspects of working at the patent office that enhanced his science?
I don't think that there was, I mean, I can't be sure, I wasn't there. I don't think they went out partying and drinking every night. It was a fairly sober place, and he was hired right at the bottom of the rung of the ladder and slowly worked his way up. The important thing about the patent office is it gave him time to think. He did not have to prepare classes and lectures and grade papers every day. It was very much a 9-to-5 job, and at the end of the day, he could go home and he could think. He could think about the nature of space and time. He could read scientific papers. He had access to them through the patent office. He could read the current physics literature and see that Michelson in the United States had shown that the speed of light is a constant for all observers. Crazy result, but that's it. Well, what does that mean? If that is true, the implications must be X, Y, Z. And the same data that were available to him were available to everybody, but everybody, that is all the old white men, the professors at universities, were busy doing what they had to do as professors. 70, 80, 90% of their time was spent on their teaching and their committees and their lectures and what have you, and maybe only 10 or 20%, whereas Einstein could do his patent work and half of his brain was still working on relativity and other things at the same time. So I think it gave him the space to be able to write those actually four miraculous papers in 1905. And then it actually became harder for him because he did have to do some teaching, some lecturing, not much, once he was hired as a professor in 1907. And he made a few jumps, a few academic moved from place to place because he got better offers. But he spent all of his time, 100% of his waking hours when he was working on gravity. The basis for that, the ability to think deeply and basically turn everything else off, just be like a horse in Central Park with blinkers on, that came, I think, from the patent office.
Thank you so much. I want to turn it over to Beth.
Yeah, I was wondering, in his 20 years of living in Princeton, did he see himself as living in exile during that time? Or did he see himself as setting up this new life? And also, as at the Institute for Advanced Studies, did he work with students? Did he teach classes, mentor students?
Yep.
Or was he really in his own little private world?
A little of both. So remember, he renounced his German citizenship. And he said, as long as this foul, murderous regime is in power, I will never go back. And in fact, he never returned. He had the opportunity. He was invited, by the late 40s, early 50s, to visit Germany. He flatly refused. He was not interested. He had wiped his hands of the country and wanted absolutely nothing to do with it. He did become an American citizen, and he was loyal to the country, deeply grateful to the country, remained very affectionate of England and Belgium, who had saved him. But he was, like many first-generation refugees, never able to speak English without an extremely thick German accent, had no teaching responsibilities at Princeton. Probably a good thing. He was a reasonably good lecturer, but not a great one. he did have a small circle of physicists who worked with him and a couple of computers. Computers, of course, in those days were not the computers we think of. They were people who did computations.
Oh, I see.
Okay, so his general relativity equations are very complex, and if you actually want to plug numbers into them and try and solve them, it can take days, weeks, months for a single person to work through all of the tedious calculations. So he had people around him who worked with him and who did that kind of work. So he worked within a small circle. One of them had the family name of Rosen, and that gentleman's son, so Einstein, Podolsky, Rosen, EPR, is one of the late famous papers that Einstein wrote with these two other excellent physicists, where he tried to prove quantum mechanics was wrong. And he said, if quantum mechanics is right, then I can actually take two particles and I can entwine them. I can mix them together because they're waves, and then I can separate them. And if I measure the state of one of them very far away, let's say it's spinning this way, the other one will instantly reveal itself, and there is a kind of communication at greater than the speed of light between them, which is impossible, hence quantum mechanics is wrong. Okay, entanglement is now known to be a fundamental property of nature. It has been measured, is right. Quantum mechanics is right. And so with his close associates, he wrote this and other famous papers while he was at Princeton. So no, he wasn't actively lecturing, but he did travel and gave talks about what he was doing, though he himself would have admitted on his deathbed in 1955 that between, say, 1936, when he wrote that paper I showed you on gravitational lensing, and 1955, 19 years later, he didn't write anything that was a breakthrough. He tried, but he had already accomplished more in one lifetime than most physicists accomplish in 100. That was it. Science isn't easy, okay? And at some point, you kind of run into a wall, and people have picked up where he left off. There's something called string theory. That's been explored for the last 25 or 30 years. Magnificent mathematics. Glorious, just glorious stuff. Strongly suggests that the universe is 10 or 11 dimensional, not just 3 dimensions of space and 1 of time. But there are no confirmations of it yet. And it's conceivable that it's wrong too. So his life's work is still very much something that's in progress.
Thank you.
Thank you. Thank you, Michael. On behalf of everyone here in person and online, we really appreciate you sharing of your time and expertise so generously. And on behalf of the Kupferberg Holocaust Center, thank you to everyone who's tuned in. We want to encourage you to sign up for our programs on our website, and our next program is happening on Thursday of next week, focusing on Holocaust memory, Jewish identity in Argentina. Again, thank you all for attending. We hope you stay safe and